Welcome everyone back to our class. Oh, you are really study hard. Ever wondered what makes your allergies tick? Or why your lungs sometimes feel like they're staging a sit-in protest? Meet the mastermind behind it all, interleukin-13, or IL-13. This little protein is a VIP in immune regulation, pulling strings in everything from asthma attacks to skin rashes. It's been around since 1993, but scientists are still scratching their heads over its full repertoire. Let's dive into this molecular mystery. So, who's the puppet master behind IL-13? Primarily, it's the Thu cells. Think of them as the hype squad for allergic reactions. When they get activated, they pump out IL-13 like there's no tomorrow. But wait, there's more. Other immune cells like CD4 T cells, NKT cells, mast cells, and eosinophils also jump on the bandwagon. And here's a plot twist. When things get really bad, like in asthma, even your lung cells, the epithelial cells and fibroblasts, start churning out IL-13 as a backup plan. Oh, and get this, depending on who's making it, IL-13 comes in different flavors. The Th2 version is fancy, glycosylated, and weighs 17 kilodaltons. The epithelial cell version is simpler, unglycosylated, at 12 kilodaltons. These tiny differences can change how it behaves. Prête de nez, Now, let's talk about what this protein actually does. Buckle up, because IL-13 has a split personality. On one hand, it's the pro-inflammatory troublemaker, especially in allergies. It tells B cells to crank up IgE production, the antibody that screams danger when it shouldn't, floods your airways with mucus, and generally causes chaos in asthma. But hold on, it also has a softer side. In chronic inflammation or after an injury, IL-13 can actually calm things down, suppressing nasty pro-inflammatory signals like TNF-alpha and IL-1 beta, and even helping repair tissue. How does it pull these off? Through its main communication channel, the JAK-STAT6 pathway. Basically, it docks onto receptors, triggers JAK enzymes, which then phosphorylate STAT6, sending signals into the cell nucleus to turn genes on or off. It's like having a remote control for your immune system, but sometimes you accidentally hit the wrong button. Okay, let's connect the dots to real-world problems. IL-13 isn't just some lab curiosity, it's deeply involved in several diseases. First up, it's the undisputed kingpin of allergic diseases. In asthma, it's the guy telling your airways to go haywire, become hyperresponsive, and produce tons of mucus. In eczema, it helps break down your skin's barrier, leading to that itchy, inflamed rash. Then there's fibrosis, where IL-13 encourages scarring in organs like the lungs and liver, making things stiff and less functional. And get this, it's also linked to certain cancers, like Hodgkin's disease and B-cell leukemia, though exactly how it plays that role is still being debated. Because of its starring role in these conditions, IL-13 is now a major target for new treatments. Think anti-IL-13 antibodies designed to block its effects, currently being tested in clinical trials for severe asthma and eczema. It's like trying to silence the lead singer of a very loud band. So, why should you care about this quirky protein? Well, first off, measuring IL-13 levels in blood or tissues can help doctors diagnose and track the severity of allergic diseases like asthma. It's becoming a useful biomarker. More importantly, understanding IL-13 opens doors for better treatments. Blocking it effectively reduces symptoms in asthma and eczema. But remember its dual nature? That's the tricky part. We need to be smart about targeting it, because we don't want to accidentally shut down its helpful anti-inflammatory or repair functions. The future is bright, though. Researchers are exploring STAT6 inhibitors and other strategies, potentially even using IL-13 modulation in cancer therapy. So while IL-13 might be a bit of a diva, it's definitely a character worth paying attention to in the world of health and disease.